Alright, so this is the second video. We're starting with question 3. So question 3 is asking us to simplify these questions. Alright, and you essentially have four tools for simplifying. Let me just go on a quick little list here. Alright, so you have the complete. Okay, I'll say that last. You have these are the means with which you can solve these questions quickly. So you have cost, right? So everything you know and we've covered with cost. You have um, you have the 180 degree, 360-degree reductions. And you have the 90 to 70 reductions. Then you have the, keeping in mind, I put it down here so I could remember it actually. So then you have the option of removing the negative from questions like this. So remove the negative. I don't know, maybe you might have to remove the negative from a 180 question. Usually when you have a switched around one like this for the 180 360, then you just add or minus 360. So for example, if I'm given x minus 180 degrees, it's very ugly 180. So what I'll do is, so this is sine, for example, I'll say x minus 180 degrees plus 360. This choice of plus is very intentional. It's essentially saying if I started at 0 here, this angle went clockwise in the negative direction and it's somewhere here, right, in this quadrant, right, or it's backwards essentially. So I need to bring it into the positive area, which I know because that's an area, that's a part of the quadrant I know. So that range from 0 to 360 positive is a range I know and can work with, and that's why we do these reductions. We essentially want to bring these angles into ranges that we can work with without the need of like a calculator or computer. All right, so let's do, so yeah, you have here, remove the negative. All right, and then our fourth option is the complementary rule. What is the complementary rule? The complementary rule is one that says, I'm gonna write the general form first and then just quickly explain with an example what that is. So if I have sine of x divided by cos of 90 degrees minus x, which is the complementary angle to x, that is equal to 1. It could also be cos of x over sine of 90 minus x, that is also equal to 1. So complementary angles dividing each other, complementary ratios, the ratios, trig ratios, sine and cos of complementary angles dividing each other will give you 1. So what does that mean? Let's use our favorite complementary pair. So sine of 20 degrees will, divided by cos, of 70 degrees is equals 1. Alright, so this is the complementary rule, and I can show you graphically why it cancels out. Like it is oh, I can remember when I proved it that sine 20 in our example was a half, and cos 70 was also a half. These are both equals, right? So a half divided by a half is 1, right? Anything divided by itself is 1, and that's why we have this rule. So with that in mind, these are our four twos, right? We have two, one there, two, two, three, and four to kind of deal with this. And then I guess I can add a fifth tool there, which are our trig identities. All right, which is obviously tan theta is equal to sine theta over cos theta, and then 1 is equal to sine square theta plus cos squared theta. Okay, just that. Okay, so that was just a quick one there. Okay, so let's get into question 3. What's question 3 telling us? All right. Um, okay. Okay. Sorry about that. Just getting my screen orientated nicely. All right. So question 3, we have 3.1. 3.1 started all the way on the left there. We have, and it's really important that you copy these things as accurately. Accurately. Be very careful, because one small mistake will change the entirety of your long answers. So here we have 90 degrees plus theta times sine of theta minus 180 degrees times tan 180 degrees minus theta. Okay. Over cos squared 180 degrees plus theta. So the way I like to tackle these things is I like to think of it as kind of like you know, though, when people use metal detectors on the beach or on a random plot of field looking for like metal under the ground, right? I like to think of my process and my thinking, the way I think about it like that. It's like I peruse over this thing and wait for my metal detector to go ping, 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 ping. So if I identify any one of these four or five things, then I kind of know they want me to do something with these things here. All right. So for example, here I'm seeing a 90 plus, so my head is going ping, 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 ping. There's a 90 reduction there. Here I'm seeing sine minus 180. My head is going ping, 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 ping. At theta minus 180. Sine theta minus 180. So there is a reduction here with a plus 360 inside of it. And then here I'm looking at tan. This one is normal. It's going ping, 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 ping for a normal 180 reduction. Here, this one's very interesting. This cos here is very interesting. It's got a squared, right? It's got a cos squared. So that should be very interesting in terms of how I change this. Will the cos squared change anything? So let's see that, right? Let's see what happens. So we've got sine 90, right? Immediately I'm going to reduce that. It's a complementary reduction. So we've got cos there, cos of theta times here we have, this is equal to, I'm just going to put it here on the side, sine of theta minus 180 degrees plus 360 degrees, and that gives you this sine of, okay, that gives you, I'm gonna put it here, sine of 180, because 360 minus 180 is 180, 180 plus theta. All right, and 180 plus theta, that's the third quadrant. and sine is negative in that quadrant. So we have a times negative sine theta. Okay, and then we move on to our tan. It's tan 180 minus theta. That's the second quadrant. Tan is definitely negative in that quadrant, so we have a negative tan theta right there. All right, and that's all over cos square. All right, so this is the third quadrant. Cos is negative in that quadrant, so we're going to have a negative cos square theta. Cos square theta there. All right, so now let's solve this, right? We have cos theta times, you see how I'm saying times, but I'm not forgetting my signs, my negatives here, times negative sine theta times negative sine theta over cos theta. That's my identity there. And then this is all over negative cos squared theta. Okay, so I can definitely cancel out here, cancel there, because these are over 1 individually, but I'm not writing it like that for the sake of speed, right? Okay, so now at the top of this fraction, I've got a negative sine theta times negative sine theta, so I'm going to have positive sine squared theta, and that's over negative cos squared theta, and then therefore my answer is negative tan squared theta. All right, moving on. We've got 3.2. All right, we've got, this one was really tricky for me to conceptualize when I was doing these questions earlier this morning, but we'll see. Let's see how we can go about it. So we have sine 330 degrees times cos of 125 degrees over sine of 145 degrees times cos of 180 degrees. So, right, we see like really weird angles here. So immediately I know that I'm supposed to be reducing these, right? So let's try and reduce them. We work with the reduction that's easiest. Let's work with the 180 reduction, or 360. 330 is in the fourth quadrant, so I'm going to say 360 minus 330. That gives me 30. And so if I get the angle 30, I'm very happy because of my special triangles. I know 30 is a special angle. All right, I know that the sine of 30 is 1 over 2, and this is a root 3, right? So this is it gives me constants. So let's see what we got here. We've got sine of 360 degrees minus 30 degrees. And then we have cos here. Cos is in the second quadrant, so I'm going to go 180 minus 125. That gives me 55. So 55 is in a special angle, which kind of goes against the precedent that was set here. So clearly this is not going to be a straightforward special angle reduction question. This is cos 55 if I use a 180 reduction. Okay, so let's just put that on the side there, because it's a 55 degree. So with that in mind, I then knew, so this is the 181, right? And then I tried the 91 instead as well, the 90 reduction, and this one would be, what's 125 minus 90? That's 35. So there, it's 35. Okay, so that's essentially, that's 90 plus 35 will give you 125. Okay, all right, so I just put that there and kept that in my mind for the sake of just being cautious. All right, just being cautious. And then here we had sine 145. Sine 145 is another weird one. When I tried 180 minus 145, I got 35. Okay, so now there's something going on here, right? 180 of that other one is giving me 35, 35 degrees. Now, immediately, I need to know that there's something going on here. I need to then check, is 55, are 35 and 55 co-interior angles? So I'll say, what's 90 minus 35, for example? I get 55. So yes, they co-interior. If that's the case, my head is going bing, 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 bing. We need to be working with some kind of co-interior, co-interior, co-interior reduction. You have to forgive me for the sounds, man. They help me think. They help me think. It's like a game show in my head. Anyway, um, so now I'm gonna do this. I'm gonna do this. This is equals to cos of 90 degrees plus 35. And I'm doing this with some a means of excitement because I know I have the co-interior rule. So if I have cos of 55 here, if I'm gonna get cos of, I mean sine of 55 here, if I can turn this into cos of 35, then I can mathematically make them equal 1, and there can be a simplification there. But let's see how this goes. So that's what I'm aiming for. I'm actually working this out with the goal to cancel and simplify there. So here I'll reduce this into sine of 90 degrees plus 55. Why have I chosen this? I'm doing this with a goal. I know that if I reduce this, this is going to be sine of 35, and this is going to be cos of 55. And remember what we said, sine divided by cos of co-interior angles is equals to 1. So I'm aiming for this, right? And then here I can reduce this. So cos 180 is on a one of the boundary lines. So usually I just put that in my one. You should just put that in your calculator. Cos 180 gives you minus 1. So this is all multiplying minus 1. So with that said, sine 360 minus 30 is negative sine 30 degrees. I know that this over this is equal to 1, so we just it's like they cancel out, but we're going to just say times 1 there. All right, and then here this is all over minus 1, so we have positive sine 30 there, 30 degrees, and that final answer will give us 1 over 2, and there we go. Okay, all right, so you see how we apply these 4 things here. Identities can come up, your complementary rule can come up, your 90 reductions, your 180 reductions, and cost is always going to be something you think of. I applied in this question alone, I applied cost, I applied my complementary rule, I applied a 90 reduction, I applied a 180 reduction. I applied all of it in just this question. All right. All right. So 3.3. 3.3 gives us sine of theta minus 180 degrees times tan minus theta times root 1 minus sine squared theta, and that is all over cos of 90 minus theta. Remember what I said about the metal detector? So I've got a metal detector going off in my head about this whole thing. I'm identifying things I can do, right? So here we have a sine theta minus 180, right? So that becomes sine theta minus 180 degrees plus 360, and then tan of negative theta is this, right? Tan is negative in this quadrant, so this is negative theta, right? Tan is negative in this quadrant, so here we're going to have negative tan theta. And then this little root here is actually very interesting. I was very interested, very impressed with what they did here. So you need to then know what this identity is. This is the identity, right? And you know that this is equal to cos theta. So I'm doing this knowing that this root, cos squared theta, that this root is going to cancel out with this cos squared theta at some point, and it's going to help me with my final answer. Okay, that's that metal detector going off. So let me reduce this one as well. Cos of 90 minus theta, this is a complementary one, right? So that gives us sine of theta. All right, so here this gives us 180 plus theta. Sine is negative in that quadrant. Sine is negative in that quadrant. Let me just make sure here if I did that. Yeah, sine is negative in that quadrant, so it's the sine of 180 degrees plus theta, right? Because 360 minus 180 is positive 180. All right, so we know sine is negative in the third quadrant, so that's going to give us negative sine theta times, I like to spread these tans as soon as I can, so I'm going to get a I'm going to get a sine theta over cos theta, and then this is multiplied by cos theta, not cos squared, cos theta. So you see what happened here, this root cancelled out with the squared. All right, okay, so that all is over sine theta. All right, my favorite part of these maths problems, the part where I cancel out. So there, and that gives me negative sine theta times negative sine theta, which is positive, and that gives me sine theta over sine squared theta. Shouldn't forget my square there, over sine theta, and that cancels there, and that gives me sine theta, and that right there is my final answer. All right, okay, quickly moving on, we have 3.4. all right, with 3.4 we have sine 117 theta divided by cos 27 theta minus cos x times tan of 180 minus x sine of negative x. Okay, all right, so here this gives us, let's see what I can do. I can reduce this. Let's see, sine, that's in the second quadrant, so I'll say sine of 180. So I quickly put in my calculator, what's 180 minus 117? That's 180 minus 63, right? And then that's obviously over cos, let's see there. All right, that's over cos 27 degrees minus cos x times, so this is the second quadrant, right? So tan will be negative in that quadrant, cos. So I'm going to put a negative there, and then I'm just going to expand it. That's sine x over cos x, and that is also multiplied by negative sine x, because sine of minus x is negative sine x. Okay. Alright, so here we have sine of 63. It's positive because that's the second quadrant, degrees over cos 27. So this one's very interesting. I'm looking at these values, and obviously these aren't special angles, so I don't really know what the ratios are, but let me check if they're co-interior. So I'm going to say 90 minus let's say 63, that gives me 27. So these are co-interior. Keep that in mind. That's very good. So I'm going to say minus, so my cos there cancels with that cos at the bottom, and then we're going to have a negative sine x times negative sine x, which gives us plus, so that's minus sine squared x, and that gives us, so this is equal to 1 because these are a sine and a cos of co-interior angles, gives us 1, and then this is minus sine squared x, and then we can neaten that up to make it cos squared x, and that's our final answer. Okay, moving on to 3.5. With 3.5 we have this very interesting one. Okay, so 3.5 we had 27 to the power minus 1 over 3. Let me just make this a bit smaller. Minus 1 over 3. Yes. That's properly. Okay, minus 1 over 3 times, so there's a times there, sine negative 90. 90 being a special angle, so bells ringing off in my head, times 3 negative 3 sine to the power negative 3 sine squared x minus 3 cos squared x. So I really want you to sharpen this skill, where as you're writing your question down, your brain has actually got to be thinking about what you can do and getting excited about little things you can do. It's kind of like a foresight thing. If you've ever played chess, I play quite a lot of chess. I play chess up to provincial level, and you learn to think about things in real time, but in the future. Like in real time, you're thinking about things ahead, right? So as I'm writing this, immediately I'm seeing a 27 and a 3, so there's definitely going to be a common base there. I'm seeing 1 over 3, and I'm seeing sine 90. I know sine 90 is something I can work with because that's a special angle. I can put that in my calculator and I can find it. And then here I'm seeing sine square x, I'm seeing cos square x, so there must be that identity that makes it 1. And this is a negative 3 and a negative 3, so there can be a factorization there. So with that in mind, I'm going to do this. So I've already in my head kind of identified my possibilities here, right? So let's do this. 27, right, is equal to negative 1 over 3. If I put sine minus 90, sine of negative 90 into my calculator, that gives me negative 1. So that's negative 1. That's negative 1 over 3 times negative 1, all right? And that's all multiplying 3 And I've got a 3 there, I've got a 3 there. So I'm going to take out a common factor of a negative 3. And that gives us sine squared x plus cos squared x. Alright, perfect. Okay, it's all working out now because I can see where this is taking me. Okay, we've got, let's put it like this, 3 to the power 3 times 1 over 3 minus 1 over 3 times minus 1 gives me positive, of course, and then this is over 3 times minus 3 to the power minus 3 times 1, my identity there. Okay, now I've got constants. I could actually even just put this in my calculator, but let's see how we can solve this mathematically, right? So 3 times 1 over 3 is going to obviously going to be 1, right? Times 3 to the power minus 3, and that gives us a square root of 3 1 plus minus 3, which gives us square root of 3 squared, and that gives us 3 and 2 over 2, which is equals to 3. Final answer. All right. Okay, so we can move on to question 4 now. Let's just get that there. Oh, question 4 is our identities. Okay, identities are very interesting. So before I get in, identities identities tend to confuse quite a lot of students, or a lot of my students, because of how many possibilities there are. Remember what I said about the Euclidean? This is now for Ross specifically, but I said Euclidean can be treated as a very systematic thing because you have a very specific set of rules and laws in Euclidean geometry, but you need to learn that you can apply these laws, this very systematic set of laws, to an artistic style of maths, because it's artistic because there are many ways to answer a question in Euclidean. I'm saying in Euclidean geometry. So you have your laws and you have artistic ways, very different ways to answer these questions, right? And so you can actually, if you are comfortable and you know your laws, you can approach this in a very systematic way by canceling, going down your list one by one and trying to figure out what you see there. It's almost the same when it comes to trig identities. So with trig identities, I know my list of identities, right? It's my tan is equal to sine x, okay, x over cos x, and that applies for tan square x as well. That gives me sine square x over cos squared x. All right. Okay, right. And then we have 1 is equal to cos square x plus sine squared x. Okay, so I have my identities. And the thing with I did with these questions on simplifying the left hand side and the right hand side is they are branches of things you can do. And the thing is there's only one branch that takes you to your correct answer. So what you need to be very comfortable with is knowing that you can start answering the question, and you can, let's say you start answering the question. So this is your first step, right? The first step is pretty simple, and then on your second step you have the option whether to go left with something in the question or right with something. You choose left and you work with left, and you get another step in left and you reach a dead end, right? So you need to track back to the first branch, the first time you made a branch, and go the other way. And you find you go there, and then you have another branch sometimes, right? You pursue one, dead end, and then you pursue this one and you find your answer. Rarely what I found in the when I was doing these questions, usually all I needed was just one branch. There's the one time there were actually three options before I found the correct one. But this is how you solve trig identities. You this is yeah. This is how you solve them. You go and you iterate each of the splitting possibilities, right, until you come to your answer. Some as you go, sometimes you might get lucky and you pick the right one immediately. Sometimes you might not, and you have to try it 3 times before you get your answer. But know that the answer is there, and the answer is usually very straightforward. All right. So let's get into 4.1. 4.1. Okay, 4.1 tells us sine x divided by 1 plus cos x plus 1 over tan x is equals to 1 over sine x. Alright, so we have our right hand side, we have our left hand side. Okay, so the goal with these is usually I know we know it's trig identities. We're working with trig identities. They're telling us to prove that this side is equal to this side. You work with the complicated side. We have to work with the complicated side. So that's our right hand side. Right hand side there. Therefore, our right hand side is equals to. Alright, so I had this sine of x over 1 plus cos x plus plus 1 times cos x over sine x. So I hope you see what I did here. This is 1 divided by tan x, so it's 1 divided by sine x over cos x. And then when I tip in times, when I switch it over, I times and I switch over the cos and the sine. So that's what I got there, just for efficiency. So these are important things. You have to learn to be as efficient with your writing as possible, because there's a lot of it, and time is moving in your test. All right, so we have sine x there, 1 plus cos x, and then we have plus cos x over sine x. I could have actually written this in one question, but for the sake of showing what I'm doing, I could have just immediately written this as this, skipped this whole section here and written as this. But for the sake of explaining and showing you guys what is happening there, then it's important that I do this. So when this is the case, I've got bells ringing in my head, because I can I made the mistake now earlier on. Actually, I made the mistake of canceling, and that wasted me quite a lot of time, because I went on like this. But I didn't realize that I made the mistake of not realizing that this is a plus, so I can't cancel across a plus. It's very, very bad. So very, very wrong as well. So what now happens is I've got two fractions here, right? And now we add fractions. We have our LCD. Our LCD being sine x and 1 plus cos x there. All right, so quickly, I'm gonna do this quickly without having to write too many steps. So this is gonna be sine x times, what didn't it have? Sine x, right there. And then this is plus cos x times 1 plus cos x, and that is all divided by sine x 1 plus cos x there. All right, Let's multiply these out. We're going to have sine squared x plus cos x plus cos squared x, right? Because I just distributed that cos in right there. After that, we have sine x over 1 plus cos. I'm keeping them separate for now so that just for caution, I'm not going to multiply this denominator in. Experience and instinct tell me not to do that for now. So if I'm looking at the top here, immediately the bells in my head should be going off because I have a sine squared x here plus a cos squared x. So that's our identity. It's equal to 1. So here I have 1 plus cos x over sine x 1 plus cos x. So if we think back now to what our right hand side looked like, that's 1 over sine x. So we have this. So actually I wasn't really sure about this because mathematically this didn't seem right that we could do this, but it seems like what they want us to do in order to get our answer. So 1 over sine x, because for me the rules I know are a plus b over, let's say, x, right, will give you a over x plus b over x, and this let's see. Yeah, it's a very weird one. It's a very weird one because I didn't think this was possible, but it's what they've asked us to do here. And I tried to do it like this, and it gave a very convoluted answer, if I'm gonna be honest with you. But I'll check it again and I'll come back to you guys if there is a change there. So just take note of that. Yeah. But we have our left hand side equal to our right hand side here, until further notice, until I've confirmed that for you guys. Alright, so we move on to 4.2. Alright, so when you're answering this, you can just say therefore, or at the end, just therefore LHS is equal to the right hand side. Okay, alright, here we have 4.2. Okay. Alright, 4.2 gives us 8 over sine squared x is equals to 4 over 1 minus cos x plus 4 over 1 plus cos x. So to me it looks like the right hand side here, our RHS, is the more complicated side. So let me just let's deal with that. I'm gonna say therefore our RHS is equals to, so these are two fractions. We can't really simplify the fractions individually, so let's do the addition there, right? As we add them, we're gonna have, so our LCD is this. Our LCD is 1 minus cos x and 1 plus cos x. Okay, so there we're gonna have 4 times 1 plus cos x plus 4 times 1 minus cos x. So there, and then here we have 1 minus cos x times 1 plus So I've got bells ringing in my head right now because if I look at this denominator, 1 minus cos x, 1 plus cos x, I'm immediately, my brain is just telling me difference of two squares. But we'll get to that. Let's multiply our top here. We're gonna have 4 plus 4 cos x plus 4 my bad, 4 minus 4 cos x. That is all over a difference of two squares scenario, which is 1 minus cos squared x. Okay, so what's happening at the top? 4 plus 4 is 8. Alright, so we have 8 there. And then we have 4 cos x plus 4 cos x minus 4 cos x. So these cancel out because 1 minus 1, for example, 1 minus 1 is 0. Right, so here we have 0 in these things. So we have 8 on its own at the top. 8 on its own at the top over 1 minus cos squared x. Bells ringing in my head. That's an identity. So here we have 8 over sine squared x. And if we check our left hand side, that's identical to our right hand side. So we'll just finish off top of our answer with a very nice flourish here, and we'll say therefore the left hand side is equal to the right hand side. Okay, moving on to 4.3. Okay, 4.3 was a very simple one for me. I didn't really struggle with it, or I didn't have to go through a lot of branches with it. So we have tan x plus cos x divided by 1 plus sine x is equal to 1 over cos x. So let's deal with our left hand side because that looks more complicated, right? Immediately I'm going to spread out the tan x when we have sine x over cos x is all plus cos x over 1 plus sine x. Alright, so LCD, alright, our LCD is this here, cos x times 1 plus sine x. Alright, and this is sine x times 1 plus sine x plus cos x cos x squared. So that one multiplied with that one. Alright, okay, here we'll multiply our top out. Sine x sine x plus sine squared x plus cos squared x. Bells ringing in my head, identity at the top there. So I'm gonna have cos x excuse me, a 1 plus sine x. Okay, so we know this is equal to 1. So we have sine x plus 1 over cos x over 1 plus sine x. So this is almost identical to that other one we found in the earlier, where it's seems like they're asking us to do this. Still to be confirmed, but let's stick to this for now. Right, cos x. Alright. And therefore we'll come here. This one's less confident because of the uncertainty of this one. We'll say LHS is equals to RHS. Okay, and then here we move on to 4.4. So 4.4 took me a while actually, because I went down two separate branches before I found the third and correct one. Remember I spoke about branches in identity trig. Okay, so let's see what happened here. Tan theta over cos theta times 1 plus tan squared theta. Okay, and that's equals to sine theta. Wow, that theta is horrendous. Okay, sine theta. Alright, so our left hand side is the more complicated one, so let's deal with that. Right, so my first step was as follows. The first time I did it, right, I did this. I said, because that tan at the top, because this tan at the top, right, is equal to this one here, this one here, right, is equal to sine theta over cos theta. I said sine theta over cos theta. All of that divided by 1 over cos theta. So I multiplied this cos at the bottom into the bracket. Cos theta times let's see, cos theta plus sine square theta times cos theta over cos theta. So this is a pretty complicated and convoluted way to start about it, but it's just where my instinct took me. And everyone has different instincts, of course. So I actually misapplied this. I'm only doing it correct now. So if I end up with the right answer here, that'll be fine, but I'll show you the simpler way that I ended up finding it to kind of conceptualize what's going on here. So these two cancel out, right, which leaves us with 1, which gives us this. See, this sine theta over cos theta, theta times cos theta plus sine. This is squared, so there's still a cos there. Sine squared theta over cos. All right, so let's add that, because this is like that. All right, let's do that. Okay, sine theta over cos theta times our lowest common denominator is cos theta, so that's going to give us cos squared theta plus sine squared theta over cos theta, and that right there should give us this is going to be 1, right? Okay, this is looking like it's not gonna find me the right answer. All right, sine theta over cos theta. You should check me as well. Maybe I've made a mistake somewhere in there, but this wasn't the method that got me the answer in any case. I'll show you what did after this, but I guess this is an example of when you take the wrong thread and you need to backtrack to the first time you had an option to take, right? A choice to make, and you make the other choice instead. So this will give us 1 over cos uh, theta, and this ends up being a sine theta over cos squared theta, um, which gives us tan theta times cos. So definitely not the answer we're looking for. Definitely times 1 over cos. So definitely not the answer we're looking for. So what is the answer we're looking for? I'm going to draw a line here. For our alternative. So right off the bat, you see here there was a branching here. I could have chosen many ways to deal with this. So I'm going to choose the other way to deal with this, right? That denominator in our original question. So here's how I chose to deal with this. I chose to keep this as tan theta. Tan theta. I chose to keep this as tan theta, right? And I said tan theta times 1 over. Oh, I see. I think there lies the problem with my working here, because I kept this as divide. But anyway, this was the method that was quicker for me here. So let's focus on this. Let's not focus on here and my error-ridden explanations here. Let's focus on this one here. I've got tan theta and 1 times cos theta plus tan squared theta times cos theta. So what I did here is I distributed. That's all I did. I distributed my cos into this bracket at the denominator, and I kept my tans intact. All right. So where does that take us? Let's see where that takes us. I'm going to keep this tan intact as well. Tan theta times. So here now we have a plus, right? Plus what? So we have 1 divided by cos theta plus sine theta times cos theta over cos theta. So I need you guys to be aware what I did here. So tan squared, and this is squared and squared. So tan squared theta times cos theta is equals to sine squared theta over cos squared theta times cos theta. And that cos multiplies with the top, and this 1 over the cos multiplies with the bottom, and it gives us a unified thing there, which is exactly what I did down here. Okay, so that then gives us, if I look at this, now we have an LCD. All right, we have an now we have an LCD. I've got a choice now. Either I cancel here. Okay, no, let me cancel here. Cos theta cancels out with that square there, but we still have an LCD here under the bracket, and our LCD is cos theta, right? So I'm going to keep that tan intact, times 1 over. So if our LCD is cos theta, so that one is going to multiply with the cos. So we're going to have cos squared theta plus sine squared theta, and that's all divided by cos theta. Okay, keep going. Tan theta times, this is equal to 1. Alright, so it's times this one here. So I'm just gonna circle that, this one here. So times 1 divided by 1 over cos theta. Alright, so this one here is the same as this one here. These two ones here are the same. Alright, so we're gonna get tan theta times 1. So when I switch this to a multiply sign, the cos goes to the top. We're gonna get something like this. Alright, spread out my tan now. This is sine theta over cos theta, and that is multiplying our cos theta here, and that cancels out to give us our final answer of sine theta. Alright, there aren't many things more satisfying than figuring these things out, but like I said, look how long it took me to get to this answer, right? I chose a path, even made mistakes on that path, and I had to retrack. So there's always it's always one of two things. Either the path you took was correct, but you made a mistake, like I did here, or the path you took is not the one you need to be looking for, and you need to go to the other one there. Alright, that's how you deal with these kinds of identities. Alright, and now we deal with our final question. Alright, which is question 4.5. Alright, 4.5 goes as follows. Sine x. This was another one where I took a different path before I found the other one, but I'm going to go direct to the correct path here. Sine x times cos x divided by 1 plus cos square x minus 1 minus sine squared x. Alright, and that is all equals to tan x over 2. Alright, so left hand side is more complicated. Let's deal with that. Okay, so if you look at this, if you look at my denominator, I have options here. I have options on what I can do. Either I can turn this one into cos square x plus sine squared x. Okay, I have that option. I could turn this into another form of that identity. I could turn this into another form of that identity. So I actually went through a process of trial and error. The first thing I did was I converted this this sign. Let's see. I converted this sign, and then I tried to convert this one. But what I found was the actual correct method was to convert this right here, this 1 was to convert this 1 right here. Alright, so let's go about it. Okay. Alright, let's see. So we have sine x just give me a second. Okay, sine x times cos x, that is over this, and then I went and I said I converted this one, that one there, using my identity. So I had sine squared x plus cos squared x. Okay, so that's all one thing there, plus cos squared x. I multiplied my minus in, minus 1 minus sine squared x over there. Okay, so let's see what can we do here. All right, we've got this identity. It will give us 2 cos, right? It will give us this minus 1 will still somehow stay in there in the mix. Let's see. All right, looking at our sum, that sine squared x is going to cancel out with that, and then we're going to get 2 cos squared x minus 1. All right, cos squared x, 1 plus 1 minus, alright, that's over this. Let me see now. I think I've made a mistake somewhere. Sine x cos square x give us that and that. Let's see. Just give me a second, just quickly doing my working here to see where I made my mistake. Minus